All right, let's dive into CPUs today.
Yeah, the brains of our computers.
Exactly. Tiny chips powering all our digital adventures.
That's right.
We're cracking open a computer architecture textbook
Oh, fun.
to extract that juicy knowledge
Hmm.
about how these things actually work.
I'm excited.
Now, we know this can seem a bit like rocket science,
Yeah, a little bit intimidating.
but we're here to break it down
Make it easy.
so even your grandma could understand.
Absolutely.
So the chapter starts off
Yeah.
by comparing the CPU to a bustling city.
Uh-huh.
And so you've got these towering registers
Okay.
acting as skyscrapers,
I like it.
storing all that crucial information.
Right.
And there's the ALU,
The ALU, yeah.
or Arithmetic Logic Unit, right?
That's right.
Which is like a giant factory churning through calculations.
Working hard.
And finally, you have the control unit,
Okay.
directing all the traffic,
The control tower.
making sure everything runs smoothly.
Keeps it all in order.
It's all about teamwork in CPUville.
It really is. Teamwork makes the dream work.
Now, the source material really emphasizes
Right.
that registers are the CPU's VIP memory.
Uh-huh.
They're like express lanes for data,
Fast.
so much faster than accessing the main memory, like RAM.
Yeah, RAM can be slow.
Imagine you need to add two numbers.
Okay.
The CPU fetches those numbers from memory
Right.
and puts them in registers for super fast access.
Does express lanes.
Then the ALU steps in,
Right.
adds them up,
Does the math.
and pops the result right back into a register,
Mhm.
ready for the next operation.
Wow. So fast.
It's a constant flow.
Yeah.
Now, what about stacks?
Stacks.
The source material calls them LIFO champions,
LIFO.
which stands for last in, first out.
Okay.
It's like a supermarket checkout line gone wrong.
Oh, I see.
So imagine a stack of plates.
Okay. I'm imagining.
You always add or remove plates
Oh.
from the top, right?
Yeah, from the top.
And that's how a CPU stack works.
All right.
And it's super useful
Mm.
for managing tasks that are nested within each other,
Okay.
especially in programming.
In programming. Uh-huh.
Say you're writing code with functions that call other functions.
Oh, yeah.
The stack keeps track of where to jump back
I
to
gotcha.
after each function completes its job.
So it doesn't get lost.
Exactly. Without the stack, things could get messy.
Very messy. Yeah.
The source material goes on to explain
Okay.
that there are two main types of stacks.
Two types. All right.
Register stacks
Okay.
and memory stacks.
Right.
Register stacks are like a small, super fast notepad in your pocket,
Quick notes.
while memory stacks are more like a spacious but slower filing cabinet.
Slower, but more room.
So it's a trade-off.
Yeah. Makes sense.
Now, CPUs have their own language.
Oh, that's right.
They don't speak English,
That's
right?
like Python.
Exactly. They communicate through instructions.
Instructions.
And these instructions come in different formats.
Okay.
It's like different dialects for the same language.
I see.
The source material mentions
See.
single register, general register, and stack organization.
3 formats. Okay.
So imagine you're explaining how to bake a cake.
Baking a cake. All right.
With single register format, you only have one mixing bowl.
1 bowl. Okay.
You can only work with one ingredient at a time.
That's limiting.
General register format's like having multiple mixing bowls.
It's more flexibility.
And stack organization is like a super efficient system
Uh-huh.
where you can easily stack and unstack ingredients as you need them.
All right. Like a well-organized kitchen.
So different formats
Yeah.
affect how efficiently the CPU can handle data and instructions.
That makes sense.
It's about finding the right balance between simplicity and power.
Definitely. A balance is key.
Now that brings us to addressing modes.
Addressing modes. Okay.
If instruction formats are the language of CPUs,
Yeah.
addressing modes are like giving directions within that language.
Oh, I see.
Imagine you need to tell someone how to get to your house.
Okay.
You could give in your street address,
Oh.
which is like direct addressing mode.
Makes sense.
Or you could say, go 3 blocks north from the library.
Oh, relative to a landmark.
That's relative addressing mode.
Cool.
So different addressing modes
Uh-huh.
offer different ways to pinpoint the location of data in memory.
So the CPU knows where to go.
Exactly. The source material lists several main addressing modes,
Okay.
each with its own quirks and benefits.
Like what?
Implied mode.
Implied mode.
Everyone knows where the